Want to know what electrical engineering is really like? Which classes are the toughest? And how to pick the best focus so you land your first job after graduation? Today, we're diving into the complete electrical engineering roadmap, University Edition. We've broken down the entire degree into 4 key parts: foundational subjects, core electrical engineering courses, specialized electives, and your final capstone project. Heads up, every university does things a little differently, but the ideas we cover here apply to all electrical engineering students. So buckle up, and let's get started. Your first big challenge as an electrical engineering major is tackling your general education and core classes. These courses aren't just extra work, they're designed to help you grow as a well-rounded engineer, not just someone who blindly applies Ohm's law. Take these classes seriously and pick subjects you enjoy. It'll make your time at university more rewarding and help you develop personally. Alongside these, you'll start your basic math and physics classes, the foundation for everything in electrical engineering. Expect to study calculus, everything from simple limits to complex triple integrals. Linear algebra will teach you how to work with matrices and handle data efficiently. Differential equations help you model real-world systems like springs and circuits. Physics courses begin with mechanics, then move into electricity and magnetism, thermodynamics, and a bit of quantum mechanics. Pay special attention to electricity and magnetism, it's going to be your best friend throughout the degree. A quick warning, many engineers say these math and physics courses are the hardest part of the degree. The fast pace and difficulty often shock students used to high school, and this stage sees the most dropouts. To help you get through, we've linked some great study resources in the description, so don't forget to check those out and subscribe for more insider engineering tips. Now for the heart of the degree, the core electrical engineering courses. These classes teach concepts you'll actually use every day on the job. At the center is your Introductory Circuits course, often called E101. This class covers how to solve DC and AC circuits, and introduces basic components like resistors, capacitors, and inductors. This is the foundation for nearly every other EE topic. Next up are courses like Signals and Systems, where you learn about feedback and mathematical tools like Fourier and Laplace transforms. Electromagnetics takes a physics approach to explain how electric and magnetic fields work. And Analog Electronics dives deeper into components like diodes and transistors. Once you've covered the basics, it's time to specialize and explore what really interests you. Many students dive into power engineering, learning how electrical energy is generated and converted. This can lead to careers in solar energy, electric vehicles, and power plants. Others focus on RF and telecommunications, studying high-frequency circuits and electromagnetic waves. These students use specialized lab tools like network and spectrum analyzers. Robotics and mechatronics combine electrical, mechanical, and computer engineering for designing robots and automated systems. Some go into integrated circuit design, creating tiny chips that power all kinds of devices. These courses build on your knowledge of circuits and electromagnetics. If programming and digital systems excite you, digital control and signal processing teach you how to build electrical brains, microcontroller systems that interpret inputs and control devices. Think of the software that helps a Tesla drive itself. There's also computer engineering, focusing on computer architecture, networks, and digital communication, prepping you for jobs in the tech industry. Feeling overwhelmed? Don't worry. The most important thing is to take courses that genuinely interest you. It's okay if your career path isn't crystal clear yet, many engineers find their niche years after graduation. Finally, after all the hard work, comes the capstone project, the highlight of your degree. This year-long project lets you apply everything you've learned by designing and building a real engineering solution. You pick your project and team, set realistic goals, and work through the full design process. Students have built relay satellites, electric bikes, and even robots that clean local streams. Choose a project that aligns with your career goals because this experience is often the first thing employers ask about in interviews. Also, try to take on a leadership role in your team, leading software, hardware, or the whole project. This shows employers you're ready to take charge. And that's the electrical engineering degree in a nutshell. After all those schematics, lab reports, and late-night study sessions, it's time to graduate and celebrate your achievement. But what comes next? How do you land your dream job right out of school? Should you consider a master's degree? Subscribe for more advice on these questions and what life as an electrical engineer is really like. Thanks for watching, and see you in the next video.